There are two types of parameters that can be used in functions. One is considered a call by reference, and the other is a call by value. The biggest difference is that the call by reference allows the function and the main program or the calling program to point to the same address that contains the value of the variable. So if the function changes the contents of a variable passed by reference, the new value is now available to the main program. Another way to think about the call by value is that a copy of the argument's value is passed to the function. Changes to this value in the function do not affect the original value. Let's take a look at two examples. Let's start with call by value. In this callbyvalue.cpp program, we have our function defined above the main. The comment says this function adds 5 to A and B temporarily since they are call by value arguments. The function header or the function signature has a return type of void. It does not return anything. The name of the function add5 and the two values int A, int B are received from the calling program. We print out a message just so we know what's going on, entering the add5 function. We print out the value of A and B before we add 5. Then I have A plus equals 5 and B plus equals 5. This adds 5 to the original value A. Then we print out A and B after adding 5. Then we leave the add5 function, which returns control back to main. Okay, here's the main. The main says let's start A out at 10 and B out at 15. We'll print their values out. We'll call the add5 function passing 10 and 15 to the function, and when we come back, we'll print them out again. Let's run this program. Okay, I'm going to make my console window bigger. The first line says A and B before calling the add5 function. A is 10, B is 15. When I enter the add5 function, A and B, A is 10 and B is 15. A and B after adding 5, A now changes to 15 and B changes to 20. So far so good. We leave the function. But now when I get back to the main calling program, notice that after calling the add5 function, A goes back to the original value of 10 and B goes back to the original value of 15. That's because we only had copies of these values in the function. We were not pointing to the actual values that were in the main. Let's see the difference between this and the call by reference. The call by reference program is exactly the same as the call by value, except for in the parameter list I have added an ampersand after the data type int. So it has a return type of void. It's still called add5. The only difference is I have this ampersand here, int ampersand space A, comma, int ampersand space B. The ampersand indicates to the program that A is a reference variable. That means it's not going to actually create its own space and memory for A in the function. It's going to update the A that exists originally from the main. And same thing for B. We're going to add 5 to A and B. And in the main, we're starting out with 10 and 5. We're calling the add5 function, and then we're going to print out A and B after we call the function. Okay, let's go ahead and compile this. Now let's run it. Okay, now the difference here, let's take a look. A is 10, B is 15. We add 5 inside the function and get 15 and 20. What's different here is that A and B, after calling the add5 function, now have the new values of 15 and 20. That is because the function and the main shared the programs because of that ampersand made those variables reference variables. When we start working with classes and other data structures such as arrays, we will see more examples of call by reference. Primitive data types are the only values that can be used as a call by value argument.